Alright guys, welcome to another episode of the GLSL tutorial series, and in this video we are going to make a vignette shader. In case you can't really imagine what this looks like, we're going to have a look at it in a second. But first let's have a look at what we actually have right now. If you're following the series, you see that there's still an old earthquake shader, which is not really the best example for a shader, but it served well in the last episode. And yeah, at first let's remove this and replace it with some actual example shader here. So first you will notice that I did this here and this here. This just sets the camera position and zoom so we can see a little better, and this just doesn't always spit out this yay shader compiled because it was kind of unnecessary. And next we'll just use the pass-through Vertex Shader here and the Vignette Fragment Shader here. So we didn't write them except the pass-through one, but we're going to write the Vignette one in, well, this episode. I just have one as an example right here. We're going to delete it though. So let's take all of this shader communication with the uniform variable that sets the distort and just move it into the resize method and actually let it set resolution to width and height, because that's what our shader needs, and that's what our pass-through shader actually oh, well, it has nothing to do with the pass-through shader, but that's one of these variables that our vignette shader is going to need. So let's see what it looks like. Great. Not. Okay, so what's the problem here? I should probably set that correctly, because the U resolution, as you can see here, is actually vec2 and not a vec3, but I passed in (0), which was unnecessary, so it didn't find the variable. So here we go. This is what a vignette shader looks like. It's got this bright in the middle and black on the sides, out of this ellipse, and yeah, you know, I don't have to explain to you what this looks like. It's a little bit of an exaggerated example so you can see clearly. We'll make this look a little bit nicer, and you will certainly adjust it to your likings in your game. Okay, so let's just delete the one that I currently have and get started writing our own one. So there we go. Goodbye. And we'll just copy the pass-through ones and name them Vignette. The pass-through shaders are always a good starting point. Okay, so the Vignette Vertex Shader is going to stay just exactly the same because we don't want to edit or modify any of the vertex positions. We just want to change the pixel color. So let's go into the Fragment Shader, and the first thing we're going to do, there is this uniform resolution missing. Do you see that? Because we are setting it here in the screen, but we don't have it in code. This won't crash because we set shaderprogram.pedantic to false, and if you do this, it doesn't crash if the variables are not actually in the shader. But that doesn't really make any sense to set it then. So let's just go ahead and create it. I think this makes sense. So uniform vec2 u resolution. Okay, the next thing we want to do is we want to take this here. This is the actual color that we would like to set without any effects, and move it into a variable, which is going to be a vec4 because any color consists of the RGB and A channel. Let's just call it color and put that in. Okay, so right now, if we start this, at first I have to change the names here to Vignette, and the other one is Vignette already from the example. So let's see what this looks like. And we'll see, this is just a plain old pass-through shader, nothing special, nothing exciting here. So let's change that. Okay, so the first thing that we want to do is actually, let's have a look at this image that I drew here. So you see there is our tile map again, and kind of, I guess you can already see the shape of the vignette shader. the red circle here, actually let's add another red circle that goes from like this a little bit, and this is the inner red circle. So we want to have the area in, let me just select this. This area here is going to be all black because that is out of the outer circle, as well as this area here, this area down here, and the area in the bottom left. And the area inside the inner circle is going to be all, well, white, all nothing on the alpha channel, so it's going to be the actual pixel color. And the area in between the inner and outer circle is going to be where the color, the alpha channel is interpolated, so where it kind of fades from black to white. Next, we got this red line right here, which simply marks the center of all these circles here, and yeah, the radius. Yeah, it's actually the radius. And also the blue one, but we'll get back to that later. So at first, what we need to do, let's just go in code and you'll see. Okay, so what we want as first step is a vec2, and that is going to be called relative position, because it's the position relative to the center of this whole image here, and it's going to equal a few things. So at first we're going to, I'm just going to write it down and explain it. GL coord is a built-in coordinate in GLSL that tells us the coordinate of the current pixel. So for example 0, 0 or 1280 times 720 for the other side. And we're going to take x and y of that and divide it by our resolution. So the resolution is already a vec2, so it only has x and y. We don't need to specify this. We could, but we don't need to, so we are not going to do it. And from this we will subtract 0.5. Okay, so why that? Let me get the calculator here and show you. This GL coord, for example, if we are in the middle of the screen, exactly right there, the GL coord for 1280 times 720 pixel resolution is going to be, well, 1280 divided by 640 on the x-axis. And we will divide this by 1280 again, our resolution. So this is what we're doing here in this step. And we'll get 0.5. Now 0.5 is kind of normalized. If we had 0, we would be all the way on the left side, so 0 on the x-axis, and if we had 1, we would be on 1280 on the x-axis, all the way to the right side. But we have 0.5, so that means we are actually in the middle. Now we want to have the relative position and not just the position of the center. So we subtract minus 0.5, because if we do this, minus 0.5, we get 0 again. And yeah, if we have the pixel in the middle of the screen, we have 0 difference as relative position to the middle of the screen. So that's exactly what we wanted. Now what might confuse you is, if we have, for example, 400 as the x-coordinate, and we divide this by 1280, we get this. And if we subtract 0.5, we get a negative number. And there certainly is no negative x-coordinate for any pixel on the screen. They are all from 0 to whatever your resolution is. But that doesn't matter. We're just going to do it anyway, because in the next step right here, we are going to create a float called length for length. But as you can see, length is reserved, so we have to use length. And actually, we're going to use this reserved function here and pass in our relative position vector. So what's this do? Well, the length function simply returns the vector length. And you probably remember what that is from school, but I can also just show you real quick. Just real quick. Yeah, whatever. And let's just get this line tool here. Yeah, fine, whatever. So if we have this vector, that what we remember, we have minus stuff here. Actually, that was a different number before, but we have a negative number, and that's the point. That's not possible. So we're going in the left direction on the x-axis, and we're also probably going into some other direction on the y-axis. And now the vector length is the length of the line between those points. Okay, so this line is what we want to get from the length method. Let's just close this image here, and we're back. And back in code. Okay, so the length is always positive, because these points can't be closer than 0 to each other, if you just remember the image that I just closed. So this is always going to be positive, and therefore it doesn't matter if we subtracted more than what it actually was. So if you got a negative number here, a negative x or y, it doesn't matter, because this is always going to turn it positive. Now the vector length actually is what we're going to use as this blue line here. So the image I just drew had the vector length go like a line like this, but it's just a number, okay? So we don't have to actually let this line go like this. We can also do it like the blue line here. If we have 0 as vector length, then we know that we are in the center, because we are not starting from down here, we are starting from the center right here, because that's the relative position that we calculated. So we are starting from the center and then going into some direction according to the vector length. So for example, if we are in the middle of the screen, the vector length was 0, and we would just stay right here and edit the pixel right there. So that's fine. Okay, let's just continue, and you'll see what this is all for. Now the actual magic comes in this float called vignette, and this is going to be a float from 0 to 1, and it's going to equal smooth step. And smooth step takes 3 variables. So the first one is going to be .5. Now what is this .5? Have a look at the image again. .5 is the radius, and the radius goes all the way to the outer circle. Okay, so the outer circle is where we wanted to start applying the whole transparency nut. from outwards of the outer circle, we wanted it to be totally black. Inwards, we wanted it to fade in, and from the inner circle, we wanted it to be totally white. So we just define the radius of the circles. The outer circle's radius is certainly .5, because it goes all the way to the left or right or top or bottom. And the inner circle, let's just say that's .25, so it's just in the middle of them. Or let's actually say .4, so we can see it good. So the radius of the outer circle is .5, going all the way to the left, and the radius of the inner circle is .4, going, well, just to here. And we are going to get an interpolated value between those, but we have to actually provide this value. So we want to have this for the vector length. So this is what I'm talking about. If we have a vector length of 0, we would be even under .4, because 0 is smaller than .4. And this would tell this smooth step function, okay, we are inside the inner circle, so inside here we don't want to really apply anything. We want to just let it how it is, and therefore it's going to return us 0. But if we have a vector length of, for example, .45, we would be just in between those two circles from the radius, because the vector length is basically the radius of the kind of imaginary circle that we are actually calculating right now the transparency for. So it would interpolate the value between the outer and the inner circle. And yeah, the outer one's radius is .5 and the inner one's is .4, and with our .45 vector length / radius, we would get some interpolated value in between those. Now, for example, if we have a vector length of .5, we would be just having exactly the same radius as the outer circle. So from there on, and for bigger values, we're going to get 1. So basically, let me just draw another line here in this absolutely amazing blue. For any values in this area, we are going to get 0. For any values in this area, we're going to get an interpolated value. And for any value slash vector length in this area, we are going to get 1. So it never gets out of the 0 and 1 bounds, and we just know exactly with what we have to apply. Inside here we have to apply 0 of transparency, here we have to apply 1, and here we have to apply the interpolated value of transparency. Okay, so that was a lot of talking. Let's actually see this in action. But we need one more thing to do this, and we want to set the color RGB to, well, we now want to actually mix this vignette in here. So we use the mix function, and the mix function takes 3 parameters again. The first one is the original color that we want to mix this with, and this is obviously color.rgb. The next one is color.rgb times vignette, because we can't just apply the pure vignette 0 to 1, because that would just be white or black. We have to actually mix this with the color that we were given to be able to see at least some of the image behind this. And this is why we use the mix function. And then we can define like the ratio between those. So if we said 0, we would probably, I don't know, we would either get all of this or all of this. It happens to be that we would get all of this, but if we said 1, we would get all of this. We are just going to say 0.5 or 0.7, so we get more of this, but not all of it, so we can nicely see what's going on. And yeah, that's actually it. The Vignette Shader should now work. Let's check it out. And yeah, there we go. There it is. It actually looks pretty much like on this image right here. Let me just, yeah, I mean, you can see it. Okay, so there is the outer circle, there is the inner circle. Here we get all the transparency applied. Here in the middle we get 0 transparency applied. And here in between it interpolates using some, I don't know, interpolation function, whatever. Okay, so now let's make this a little bit more flexible to finish off. Let's say we want to define a few variables up here. We can actually just define them as constants. We could also let this const keyword away, but if we use it, which is what the name already suggests, we cannot edit, modify the values of these variables later. So let's just say we have a few float constants here. The first one being radius, and we are going to set this to 0.5 because, well, the radius from the middle to, well, the outer border is 0.5, since 1 is the whole length of the window. And we are just going to say, instead of the outer circle here, radius, because this would be the outer circle radius. Then we could also say inner circle radius. Yeah, let's actually do that. Let's say outer radius and inner radius. And set that to 0.4. And yeah, we already have 2 values that we can easily edit. Then let's say intensity for this one here, and intensity is going to equal 0.7. So now this should be the exact same. Let's start it up again. And it is the exact same, but now we can easily edit it. For example, let's say intensity 1 dot. Bam! And we get none of the original image out of the outer circle. Or intensity 0 dot. Well, we don't see anything. Intensity .5 probably looks pretty nice. Yeah, it actually does. But I like a little bit more now. .6, for example. Yeah. And let's make the inner radius .3. So we'll get more interpolation here. Or .1. This already looking pretty cool. We could actually even set the outer radius farther out, like not just to this position, but to this position here. So let's say .65 and the inner radius to .4 again. And yeah, we'll just get these darkened corners, so we don't have the actual circle on the screen. So that's all things that you can do, but there's one more thing that I want to show you real quick. Let's say, I mean, it looks kind of not so good in my opinion, but let's say we want this to be a round circle. Just like we would have a round circle if we actually made this a proper square. Now we have a round circle, but let's say you want to have the round circle even though it isn't a perfect square. Yeah, that's possible, no problem. We would just go ahead and set the relative position.x. Position.x, yeah. And we would multiply that by the ratio of, yeah, but the aspect ratio of the window. So this would be u resolution dot x divided by u resolution dot y. And I think this should be it. Yeah. Now we have yeah, some kind of nice circle. Fine, we could also experiment around and see what happens. That's kind of not so good. But if we, for example, wanted to modify the y, now this is what happens if it's not so good, because now that we set the y, we have to change this order, I think. And yeah, now it always sets it to the height of the window. So let's make it a little bit, yeah, like this. So you see what I mean, okay? Alright, so I'll just let this in here, but I'll comment it out, and in the repository you can see if you want to use it or not. Is there anything else that we can do? Not really. For a full text explanation of this, actually, go to the site that I'm going to put in the description, because actually this tutorial was like a video tutorial version of the tutorial that David's made. He put this all in his GitHub site or whatever and described that pretty well. Go check that out if you are more into a text version of this instead of listening to parts of the video again. Okay, so thanks for watching, and I think that's it. I'm going to upload this into the repository, have fun doing stuff. I'm hopefully going to see you in the next episode. Until then, have fun.